Hello students, today we'll be discussing about hydrocarbons. What are hydrocarbons? Basically, they are the compounds that are formed by carbon and hydrogen. Okay, now hydrocarbons. Hydrocarbons are the compounds of carbon and hydrogen. So all compounds of carbon and hydrogen are known as hydrocarbons. Now in the vast branch of organic chemistry deals with the study of hydrocarbon and its derivative, means the compounds of carbon. Okay, so we tell that branch of chemistry as organic chemistry, okay, where we deal with the study of the compounds of carbon and hydrogen, that is hydrocarbon and its derivative. So we'll take a basic introduction. What is hydrocarbon and how do we classify it? Okay, so first we'll see the types of classification we can do to hydrocarbon. Types of hydrocarbon. Now broadly, hydrocarbons are categorized into two categories. Okay, one is saturated hydrocarbon and the other is unsaturated hydrocarbon. Okay, saturated hydrocarbons, these are having only carbon-carbon single bond. That is, carbon is bonded to carbon. There is a single bond present. Whereas in unsaturated hydrocarbons, we see that carbon is having either double bond or it can have triple bond. Okay, one of the carbon will be having double bond or triple bond. Then they are said to be unsaturated. Okay, so saturated means the presence of the single covalent bond and double bond, then it is an unsaturated hydrocarbon. Triple bond, then also it is an unsaturated hydrocarbon. So we will be studying these two types of hydrocarbon, how they are further divided. So the first category, it is saturated hydrocarbons. So these are compounds of carbon and hydrogen. Okay, they are having carbon-carbon single bond. Okay, that is, no double bond or triple bond is present in the structure. For example, if the carbon skeleton is like this, okay, then it is a saturated hydrocarbon, where the other three valencies of the carbon are completed by hydrogen in the terminal cases. Okay, so here now here we can see, as there is only single bond present between the carbon, so this is a type of saturated hydrocarbon. Okay, so the important point for this was that presence of carbon-carbon single bond. Okay. Now saturated hydrocarbon, we are going to study its main type, that is about the alkane. It is further divided into alkane. Okay, alkane are basically the open chain hydrocarbons. They can be cyclic hydrocarbon and acyclic hydrocarbon. So the open chain hydrocarbon, these are also told to be alicyclic hydrocarbon. Now another name for alkane is given as paraffins. Paraffins, what does this mean? It is meaning, para means less and affins means affinity. Okay, so you can say paraffins means little affinity. So the alkanes, they are having little affinity or they are mostly unreacted by most of the chemical reagents, so they are said to be paraffins. Okay, so you can see that they remain unaffected to many chemical reagents. Okay, and so the name paraffins is given to them. Now we'll see how can we identify an alkane, or how can we say that this hydrocarbon is an alkane or not. Okay, that we can see just by knowing its general formula. Okay, general formula of alkane, that is the general formula of alkane is CnH2n plus 2. Okay, where n is an integer. Okay, 1, 2, 3. It can be so on. So this is the general formula of an alkane. Now here we can also write the name of the alkane by knowing the integer. For example, if n is equal to 1, then the alkane formed will be CH4. Okay, this is methane. As there is present one carbon, so the name meth is given to it for one carbon, and a suffix "ane" is added for showing the saturation in the compound. That is, there is not present any double or triple bond. This shows that the compound is saturated compound. Okay, so the name to this compound is given as methane. Okay, similarly, if n is equal to 2, okay, we use the here it represents that 2 carbon atoms are present, and ane is showing the saturation. So the name given to this is ethane. Similarly, we can write down more alkanes. If n is equal to 3, then it will be C3H8, and the name given to it will be propane. N is equal to 4, C4H10, and the name given to it is butane. So in this way we can write down the alkanes, okay, by giving the number n and placing it in this general formula. Now we will be discussing about some important physical properties of alkane. Now alkanes exist in all the three states, solid, liquid and gases, from C1 to C4, that is from methane to butane. These all are gases. They exist as gases. C5 to C17, where the hydrocarbon, it is having 5 carbon atoms, then in its chain then it is C5 pentane, and up to C17. If there are 17 carbon atoms in a straight chain, then they are liquids. And above 17, that is if there is present more than that, they are solids. Then the alkanes, they do not have any smell or any color. Okay, they are colorless and odorless. Next is they are soluble in non-polar solvents like benzene, carbon tetrachloride, that is CCl4. So these are soluble in non-polar solvent and are insoluble in polar solvents such as water. They will not be soluble in water and other polar solvents. The next important physical property is the boiling point. Boiling point of alkanes increases with increase in molecular. So methane will have less boiling point than ethane, which will have less boiling point than propane, and so on. So as the number of carbon are increasing, the molecular weight is increasing, and so will the boiling point of alkane also increase. So these were the general physical properties of alkanes. Now after studying the type of saturated hydrocarbon, that is alkanes, about alkanes we have discussed some physical properties. Now we will be discussing about the second type of hydrocarbon, that is unsaturated hydrocarbon. Unsaturated hydrocarbons, these are hydrocarbons, that is the compounds of carbon and hydrogen which are having at least one double or triple bond. Okay. Now the unsaturated hydrocarbon, they are further categorized into two categories, that is alkenes and alkynes. So we will be discussing the first category, that is alkene. If there is present carbon-carbon double bond in a compound, then it is an unsaturated hydrocarbon and the type it is belonging is alkene. Okay. Alkenes, these are having general formula CnH2n. General formula is CnH2n. Here n is equal to 2, 3, 4 and so on. Okay. There cannot be n is equal to 1 because for a double bond to exist, at least 2 carbon atoms should be present. Okay. So the minimum value for n you can give is from 2 and so on. So when n will be equal to 2, then the type of alkene that will be formed, that is having molecular formula C2H4. Okay. Now for 2 carbon atoms, as I said, we give the word ith to it, indicate 2 carbon atom present. Okay. And to show that unsaturation is present, we add ene to it. Okay. So the name to this hydrocarbon alkene is ethene. Similarly, in the next case, for n is equal to 3, the type of hydrocarbon that will be formed is C3H6. Here 3 carbon atoms in a chain, or you can say 3 carbon atoms are attached in a chain, then it is given the word prop. I add to indicate the unsaturation ene to it, and then name given to this is propene. 4 carbon atoms, so we write the word but to indicate this. Okay. And then the name given to it will be butane. So in this way we see whether it is a alkene or any other hydrocarbon by the ene. If ene is present, then it is showing that it is a type of alkene. Now we will discuss some physical properties, but before that we will see the other name given to alkenes is olefins. Olefins. Olefins means oil forming. The lower members of this type of hydrocarbon, they form oily compounds with halogen. Okay. And that is why the name olefins is given to them, as they form oil. Okay. For example, I'll take ethene, CH2, double bond, CH2. Okay. Here I am showing that the double bond is present between 2 carbon atoms. This can also be written in this way. CH, double bond is present between this carbon atom. This is the representation of ethene. Okay. When ethene reacts with halogen such as bromine, Br2, it will form an oily compound. So here the double bond is broken and there are bromine atoms attached to the carbon. Okay. So this is an oily liquid and so the name olefins is given to them. Now talking about the chemical properties, generally the chemical properties is same as that of alkane, only a few differences there that we'll be discussing. Physical properties of alkenes. Now the physical properties of alkane is that from C2 to C4, that is the alkenes having 2 carbon atoms till 4 carbon atoms in a chain, they will be gases. And from C5 to C14, they will be liquids. C15 and above will be solids. Okay. The next is they are also odorless and colorless except that of ethene. Ethene has a sweet smell. Okay. And that is why it is the only exception in this case. Then the third property is it's also soluble in non-polar solvent. Like benzene and carbon tetrachloride. The next is that the boiling point increases with increase in molecular weight. So as the molecular weight will increase, the boiling point will also increase. Now the second type of unsaturated hydrocarbon, that is alkynes. The word alkynes, that is YNES, it represents a triple bond. Okay. So if carbon-carbon atoms, these are bonded together by a triple bond, then they are showing that it is a type of unsaturated hydrocarbon, that is alkynes. Here the general formula of alkynes, it will be CnH 2n minus 2. Okay. Here N is again 2, 3 or more than that. N cannot be 1 as at least 2 atoms of carbon are required for a triple bond. Here we can see that alkyne is having 2 carbon atoms minimum for the formation of a alkyne. Here we can see that hydrogen, there is 4 hydrogens less than alkanes and 2 hydrogen less than alkenes. Okay. So the less number of, or we can say the least number of hydrogen present in an hydrocarbon, that will be in alkynes. Okay. If I compare it with the similar type of number of, when I compare it with similar number of carbon atoms. For example, I compare it with ethane C2H6, then ethene C2H4, then here it will be ethyne and it will be C2H2. So we see there is degradation in the number of hydrogen. There are 2 hydrogen less in ethene and further 2 hydrogen less from ethene than in ethyne. Now if I have to name it, as I said it earlier, if N is equal to 2, here putting it in the general formula, it will become C2H2. Now for 2 carbon atoms, I use the word ith and then I add it with the yin of the alkene. Okay. This shows that this is a compound which is having triple bond between the carbon atoms. Okay. And the name given to it will be ethane. Similarly for N is equal to 3, it will be C3H4. Now the name given to it will be propyne. Similarly butane. And if I have to see the structural representation for this, then we can see it will be in this form. For propyne, there will be 3 carbon atoms, at least one of them will be having a triple bond. Now here 1 hydrogen atom, here there will be 3 hydrogens for this case. Now we can count here 1, 2, 3, carbon atoms, then hydrogen 1, 2, 3 and 4. So the propyne will be represented in this. Now we will see the general properties of, that is the general physical properties we will be discussing about. Alkynes, these are also gases from C2 to C4. Till butane it will mean that they are gases. Then from C5 to C12 they will be liquids, and C13 and above will be solids. Next is, they are also odorless and colorless except ethyne. Ethyne has a characteristic smell, so it is an exception in this. Then they are soluble in non-polar solvents like benzene and carbon tetrachloride ether, etc. But they are even slightly soluble in polar solvents, very slightly soluble. They are having some tendency to be soluble in polar solvents, but that tendency is very less. So we can say that they are slightly soluble in polar solvents such as water. Next is that the boiling point of alkene will increase with increase in molecular weight of the alkene. The one basic difference here we are seeing, the thing is that the boiling point will increase from, for example, the boiling point of propyne will be more than that of ethyne. Okay. But if we compare it with alkane and alkene, then there will be a slight difference in this. That is that the alkynes, they have higher or slightly higher boiling point than corresponding alkanes and alkenes. For example, ethane C2H6, it is having the boiling point of minus 89 degrees Celsius. Then ethene C2H4, it is having the boiling point of minus 103.7 degrees Celsius. And ethyne C2H2, it is having boiling point minus 84 degrees Celsius. So when we compare, we see that the highest boiling point is for ethyne. Okay, so ethyne is having the highest boiling point. This is due to the triple bond present. The triple bond present will provide extra stability to the molecules and they will be tightly bonded, and that is why they will have slightly higher boiling point. So we see that ethyne has higher boiling point, ethane which has higher boiling point than. Now if we talk about the bond strength and the energy required to break this bond, then that also we can see, we can compare all the three, alkane, alkene and alkyne. We'll have a comparison view, okay, as we had it in the boiling point. So for this, the bond strength, carbon-carbon single bond, carbon-carbon double bond and carbon-carbon triple bond. The triple bond will be very strong. Okay, so the bond strength of carbon-carbon triple bond will be higher than carbon-carbon double bond, and which will be higher than the carbon-carbon triple bond. The bond strength of, or you can say the bond length of carbon-carbon single bond is 1.54 Armstrong. For carbon-carbon double bond it is 1.34 Armstrong, and for carbon-carbon triple bond it is 1.2. So as we can see, the bond length is decreasing, so its strength is increasing, and when the strength will increase of the carbon-carbon bonds, then the energy required to break this bond will also be higher. This is the order of the bond strength. And the bond length we see, it is decreasing. As the bond length is decreasing, the bond strength is increasing for this case. Now talking about the energy required to break this bond. So the triple bond, it will require higher energy as compared to double bond and single bond. Bond energy or energy required to break carbon-carbon triple bond is more than carbon-carbon double bond, which is more than carbon-carbon single bond. So this was a brief introduction about the hydrocarbons and the categories. They are divided broadly into the types. Okay.